Number 4, at time t equals 0, a boiled potato is taken from a pot on a stove and left to cool in a kitchen. The internal temperature of the potato is 91 degrees Celsius at time t equals 0, and the internal temperature of the potato is greater than 27 degrees Celsius for all times t is greater than 0. The internal temperature of the potato at time t minutes can be modeled by the function h that satisfies the differential equation given here, where h of t is measured in degrees Celsius and h of 0 equals 91. Part A says to write an equation for the line tangent to the graph of h at t equals 0. Use this equation to approximate the internal temperature of the potato at time t equals 3. So we need to do two things. Write an equation of the line, and then use the equation to approximate the temperature. Okay, if I want an equation of a line, I know that I have to have y equals mx plus b, and the only thing I'm going to change, since we're talking about t instead of x, I'm just going to change that to a t. Okay, so there are two things that I need to know. I need to find the slope, and then I need to find the intercept. So the slope is going to be the derivative, and I notice that they already gave me the derivative. I just need to find the derivative at t equals 0. Okay, so at t equals 0, if I'm just going to, so my slope is going to, I'm going to use dh dt equals negative 1/4 h minus 27. Okay, well, it says t equals 0. There's no place to plug in t right here. It only gives me an h. Well, I know up in the problem it told me that at time equals 0, h was 91. So that's what I'm going to put right there. So I'm going to have negative 1/4, 91 minus 27. 91 minus 27 is, when I multiply that by negative 1/4, I'm going to get negative 16. So my slope is going to be negative 16. Okay, so now here I'm going to put y equals mt plus b. My y is my h, which is 91, so I'm going to have 91 equals, my slope is negative 16, my time is 0, plus b. That leads me to getting that b is 91. So the equation of my tangent line is going to be y equals negative 16t plus 91. Okay, then from here it says to use that equation to approximate the temperature at time t equals 3. So now we're going to find y when time is 3, so I'll have negative 16 times 3 plus 91, which gives me negative 48 plus 91, which gives me 43 degrees Celsius. That would be the temperature of the potato. That was worth 3 points. For finding the slope of negative 16, I would get a point. For finding the tangent line, I'd get a point. And then for finding the actual temperature, I would get a point. So far we have 3 points going in this problem. Okay, part B, use d squared h over dt squared to determine whether your answer in part A is an underestimate or overestimate of the internal temperature of the potato at time t equals 3. So first of all, if it says to use this right here, we need to figure out what that means. That means the second derivative, and they've already given me the first derivative. So I just need to take the derivative of the first derivative, and then that will give me the second derivative. So d squared h dt squared will equal the derivative of this, okay? Negative 1/4 is a constant, so it's just going to tag on in the problem. The derivative of h minus 27 is going to be 1, but since this is with respect to time, we also have to include the dh dt. Okay, so now we're not quite done because this is dh dt. Well, I already know what dh dt equals, so this will be negative 1/4 times dh dt is negative 1/4 h minus 27. Okay, and if I simplify that even more, it will be 1/16 h minus 27. All right, this is the second derivative. Okay, the reason that I would want to know that what the second derivative is, to know if it's an underestimate or an overestimate of the internal temperature of the potato at time t equals 3, we need to know what this curve is doing. Is it concave up or is it concave down? Okay, since they told us that h is always greater than 27, so this number is always going to be bigger than 27, I know that this answer is always going to be positive. So since the second derivative is always going to be positive, this will be a concave up function. So we're going to have, and we've got a potato cooling, but it's going to be concave up. So it's going to look something like that. So at time t equals 3, remember in part A, we found an equation of a tangent line. So we found the equation of that tangent line. So it's asking, was that answer an underestimate or an overestimate? Since it is underneath the actual curve, it is going to be an underestimate. And the reason that it is an underestimate is because the graph is concave up since d squared h t squared is positive. Okay, and that was just worth all that work for 1 point. Okay, C, for t is less than 10, an alternate model for the internal temperature of the potato is the function g that satisfies the differential equation where g is measured in degrees and g of 0 equals 91 as well. Find an expression for g of t. Based on this model was the internal temperature of the potato at time 3. So 2 things. Number 1, find an expression. Number 2, what is the internal temperature? Okay, find an expression. It doesn't say to find an equation of the tangent line. When it says to find an expression, it's really meaning to solve. So I see it's to solve a differential equation. When we solve a differential equation, hopefully it's just buzzing in your ears right now, to cross multiply. So I'm going to put a 1 under there. I'm going to cross multiply. So I am going to get dg equals negative g minus 27 to the 2/3 dt. In order to take the integral of this, I do need to have my variables on the same side. So I need this over on the other side. And to get it over on the other side, I'm going to divide. So I'm going to have dg over g minus 27 to the 2/3 dg. Oops, I already have that. Equals negative dt. We don't need to move the negative. All right, now I have my variables separated, so I'm ready to take the integral. Okay, on the left side, since I have parentheses, we're going to be doing a u substitution, so I'm going to let u equal g minus 27. du, the derivative of g is just 1, dg. Notice I have that if I put a 1 there, so I already have my part. So if I rewrite this, this is going to be du over u to the 2/3. And if I would like to take the integral of that, we're going to move that up to the top. So it's now going to be u to the negative 2/3 du. And taking the integral of that, we'll add 1 to the power, which is going to be u to the 1/3, and then do the reciprocal on the outside, which will be 3. And then just further finishing that, I'm going to have 3. This is going to be g minus 27 to the 1/3, and then equals the right side. The derivative of negative dt will just be negative t plus c. Okay, my goal was to find an expression for g, so I want it to say g equals. So the next thing that I'm going to do is just divide everything by 3. So I'm going to have g minus 27 to the 1/3 equals negative t over 3 plus c. Before I try to continue solving this, I am going to go ahead and use this information to find the c. So g is 91, and t is 0. So that will be gone. 91 minus 27 is 64. 64 to the 1/3, the cube root of 64 is going to be 4, so I get 4 equals c. So then now I'm going to have g minus 27 to the 1/3 equals negative t over 3 plus 4. And then to finish solving this, to get rid of a cube root, we're going to cube both sides. So now I'll have g minus 27 equals negative t over 3 plus 4 to the 3rd power. And then to get g by itself, we'll just add 27. Okay, so that is my expression for g. So I found that. And then it says, based on this model, what is the temperature at time t equals 3? So now I'm going to plug 3 in there. So g of 3 will equal negative 3 over 3 plus 4 to the 3rd plus 27. And that will be negative 1 plus 4 is 3. 3 to the 3rd is 27 plus 27. I have 54 degrees Celsius. Okay, this was a big point getter on here. If, let's see, it's worth 5 points. I'd get 1 if I separated my variables. So if I got to this step right here before I took my integral, I'd get a point. Okay, if I found the antiderivative, so if I correctly, let's see, where should I be at? If I correctly got to this step right here, that would be worth a point. If I remembered my plus c, I got a point. If I actually wrote my equation so it said g equals, I got a point. And then if I found the temperature of g of 3, I would get my final point for that one. So that was kind of a crazy one. And I think that's all my points.